Good morning, everybody. How are you all? Today we will work on this particular problem, which I will share with you. Says, in a chemical reaction, a compound changes into another compound at a rate proportional to the unchanged amount according to the model dy by dt, that is change of y with respect to t, is equal to ky, where y is the amount of compound that is unchanged, t is time. Part A, solve the differential equation. Part B, if the initial amount of the original compound is 20 grams and the amount remaining after 1 hour is 16 grams, when will 75% of the compound be changed? So we will work first with part A. We have been given dy by dt is equal to ky. So we divide by y on both sides. By y on both sides. And multiply by dt on both sides of the equal to sign. To equal to sign. Okay. So we will get dy by y is equal to k dt, because we have multiplied by dt on both sides of the equal to sign and divided by y on both sides of the equation. So if I move this a little bit, now we will integrate on both sides. On both sides to get integration of dy by y is equal to k, which is a constant, integration of dt, or integrating natural logarithm of y is equal to kt plus c1, where c1 is an integration constant. Integration constant. Okay. So this can be by using the definition of ln y, which is logarithm to the base e, which is logarithm to the base e, which is the natural number. We get y is equal to e to the power of kt plus c1. Okay. Or this is equal to e to the power of kt multiplied by e to the power of c1. And if I create some more space, e itself is constant, e to the power of c1 is a constant term, because c1 is an integration constant and e itself is a natural number. Hence, y is equal to c e to the power of kt, where c is equal to e to the power of c1 is equal to a constant. Okay, so this is your solution. Okay, this is the solution to the differential equation. To the differential equation. Okay, so that concludes part A. If you have not already quit me, let me give you some tip on what we did. We basically separated the variables. We kept y on one side of the equation and t dt on the other side of the equation. Then we integrated, and we used also the definition of the natural logarithm ln. Okay, and natural logarithm is nothing but logarithm to the base e. Hence, y becomes e to the power of kt multiplied by e to the power of c1, which by itself is a constant. Hence, y is equal to c, which is the constant multiplied by e to the power of kt. E is a natural number. Okay. So now for part B, let me create some space, and we will use the information given to us. Initial of the amount of the original compound is 20 grams, and the amount remaining after 1 hour is 16 grams. Okay, so initial amount is 20 grams. So let me change the color of my ink. Okay, and we can probably use this one. Okay, so part B. Okay. Initial amount is 20 grams. Grams. And amount after 1 hour. 1 hour is equal to 15 grams. Hence, 20. So let's erase this. Okay. So substitute y equal to 20 at t is equal to 0 to get, what do we get? 20 is equal to c e to the power of k times 0. Okay. Or 20 is equal to c. Okay. That's an important finding, that the constant is equal to 20. Okay. Now plug it back. So you get y is equal to 20 e to the power of k t. Okay. So next, substitute substitute y is equal to 15. Okay, y is equal to, sorry, y is equal to 16. Y is equal to 16 at t is equal to 1 hour. 1 hour. Okay, so we get 16 is equal to 20 times e to the power of k times 1. Okay, so and this equation can be solved. Divide by 20 on both sides. Divide by 20 on both sides. Both sides to get 16 divided by 20 is equal to 20 divided by 20 e to the power of k, or e to the power of k is equal to 16 over 20, which simplifies to 4 over 5. Okay, so take natural logarithm on both sides, logarithm on both sides, to get what do we get? We get ln e to the power of k is equal to ln of 4 over 5. Now ln e to the power of k is nothing but k times ln e is equal to ln 4 over 5. Now ln is natural logarithm or logarithm of e with respect to e, that itself is 1. Okay, so k is equal to ln 4 over 5. Okay, so the final equation we get y is equal to 20 e for k. We write ln 4 over 5 times t. This is parenthesis. Okay, so this is the final equation with which we will work. Okay. Okay. So they're asking us to find out when will 75% of the compound have been changed. Okay, so let's create some space. So initial amount is amount of the compound is 20. Okay, 75% of the initial amount is equal to 0.75 times 20 or 15 grams. When 75% of the compound is used, compound is consumed in the reaction, leftover amount is 20 minus 15, which is 5 grams. 5 grams. Now we will use the equation. Use equation y is equal to 20 times e ln 4 over 5 multiplied by t. So y is equal to now 5. So this gives rise to 5 is equal to 20 e to the power of ln 4 over 5 multiplied by t. Okay, so now divide by 20 on both sides. We get 5 over 20 is equal to e ln 4 over 5 times t. Okay, So this becomes, if I create some space, this becomes 1/4 is equal to E to the power of ln 4/5 times T. Okay. Now, if I take natural logarithm on both sides, take natural logarithm on both sides, on both sides, we get ln of 1/4 is equal to ln e to the power of ln 4/5 multiplied by t. Now, using the rule of natural logarithm, the exponent part comes in the front. So this is the coefficient ln of 1/4 is ln 4/5 times t, and then ln of e. Okay. Or ln of e is 1. This is 1. And then divide by ln of 4/5 on both sides to get ln 1/4 is equal to divided by ln of 4/5 is equal to t. Now we will use over our calculator to calculate this. So if I create a little bit more space, t is equal to ln of 1/4. I will find out in my calculator what is ln of 1/4. So I press the ln key in my calculator inside the parenthesis 0.25 because that's 1/4, and that is minus 1.3863, and that is divided by ln of 4/5, which is 0.8. So ln 4 divided by 5 is 0.8, and that is equal to minus 0.2231. So this is becomes equal to then 1.386 divided by 0.223, which is 6.22 hours. What does it mean? It means by 6.22 hours, 75% of the initial amount of 20 grams will be consumed in the chemical reaction, and only 20 minus 15, which is 75% of the initial amount, will be left over at 6.22 hours. Okay, so the time frame for 75% of the initial amount to get consumed is 6.22 hours. So let me recap what I did. First, in part A, I solved to find the equation for the amount of the compound, which is at any point after the reaction, is y equal to c multiplied by natural number raised to the power of kt, where c is a constant and k is also a constant, t is the time. Now we will go into part B. Initial amount is 20 grams. That means at t equal to 0, initial amount C is 20, Y is equal to 20 rather is equal to C multiplied by E raised to the power of K multiplied by 0 because initial time is 0. So with that, we solve for the constant C as 20. Now, when also it is given to us that amount left after 1 hour is 15 grams. Why do we need that information? Because we will plug it in the equation to okay. Uh, so we get to solve for K. How do we solve for C? Because we know at 1 hour, after 1 hour, 16 grams is actually it should have been 15, right? So let me look at the original amount, original question. 16 grams, not 15 grams. So 16 grams, yes. Okay, so 16 grams we solve for A, so we plug at t equal to 1, substitute t is equal to 1. So 16 divided by 20 is equal to 20 divided by 20 e to the power of k. So e to the power of k is 16 divided by 20, which is 4 over 5. And then we take natural logarithm on both sides to solve for k. K turns out to be ln natural logarithm 4 divided by 5. Now we want to find out by which 75% of the compound is consumed, but we have to work with the amount left, which is 20 minus 15, which is 75%. Only 5 grams is left. So plug in the equation for y, substitute y, for y substitute equal to 5 because 5 gram is left. 20 multiplied by e, natural logarithm, natural number raised to the power of ln 4 over 5 over t. Our goal is to solve for t. So we divide by 20 on both sides. Then we take natural logarithm further and we get uh, t is as equal to ln of 1/4 divided by ln of 4/5, which works out to 6.22 hours. I know this is a long problem and there's a chance you might get lost, but if you have any question, you can easily ask me. I will, or write a comment. I'll get back to you as soon as possible. If you like this video, give me thumbs up. Okay, I appreciate that. If you do not like this video, give me thumbs down. Then I'll learn from my mistake and try to improve on my next video. If you like this video, share with your friends. You and your friends subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to watch me tomorrow when I'll be back with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day.